Communication satellites have revolutionized telecommunication and broadcasting services worldwide. Many services today, such as television broadcast, telephoning, radio networking, internet, banking communications, rely in varying degrees on these communication outposts in deep space. Starting with the direction provided by the great visionary Dr. Vikram Sarabhai in the 70s, satellite instructional television experiment was our first tryst of television broadcast through a communication satellite. With sight, television entered the home of the common man.
It will be our constant endeavor in the years to come to provide the peaceful uses of outer space for the real problems of this nation.
What followed was nothing short of a revolution. With its series of INSAT and GSAT communication satellites, ISRO strongly went forward on these lines, serving various needs of our nation. While some of the INSAT satellites carried both communication and meteorological payloads, the GSAT series is dedicated to communication services only. GSAT-17 is ISRO's indigenous communication satellite, built on its proven I-3K spacecraft bus or platform. It will provide continuity to fixed satellite services in C and extended C-band and mobile satellite services in S-band, which were provided earlier by the older INSAT satellites. GSAT-17 is structured around a 3.1 meter carbon fiber reinforced plastic central cylinder, which houses the oxidizer and fuel tanks. North and south panels of the structure accommodate the majority of payload and bus system packages. These have embedded heat pipes for efficient thermal management. This 3,475 kg spacecraft carries payloads in C, extended C and S-band. It also carries a data relay transponder and search and rescue payload. One lower extended C-band transponder will provide connectivity to Antarctica. Two deployable dual-graded reflectors are mounted on the east and west sides of the spacecraft. The Earth viewing side contains a short backfire antenna, MSS band prime focal reflector antenna, and two microstrip patch array antennas for payload. It also has a global horn and an Omni antenna for telemetry tracking and command operations. The spacecraft has deployable solar panels for generating electrical power. These are mounted on the north and south sides of the structure. These panels contain advanced triple junction or ATJ solar cells, which have the capacity to generate around 6 kilowatts of electrical power. The two solar array drive assemblies are used for maximizing solar flux on its solar panels by continuously orienting the solar panels towards the sun. The lithium-ion batteries will provide essential power to the payload and bus systems during periods of eclipse. Upon its launch, the satellite will be injected into an elliptical geotransfer orbit, in which its shortest distance from Earth, called perigee, will be around 250 kilometers, and its farthest point from the Earth, called apogee, shall be around 36,000 kilometers. The liquid apogee motor of the satellite will then be fired to raise the perigee of satellite to 36,000 kilometers, which will make its orbit circular and geosynchronous. This is called orbit raising maneuver. The satellite contains approximately 1,925 kilograms of propellant for its orbit raising, as well as for station-keeping corrections by its attitude and orbit control system during its lifetime. The creation and assembly of this satellite has been a collective effort of Team ISRO spread across the country. ISRO Satellite Center, ISAT, Bangalore, did the configuration design. development of many bus systems, testing and assembly of the spacecraft. Space Applications Center, Ahmedabad, realized the communication payload. Many other subsystems like inertial elements, sensors, propulsion, composites, etc. were delivered by IISU, LEOS, LPSC and VSSC respectively. Many industries also produced and supplied different subsystems. Master Control Facility, Hassan, will carry out all the mission operations during expected lifetime. This communication outpost is expected to soar into space aboard Ariane-5 rocket, VA-238 mission from Kourou in French Guiana on 28th of June 2017 at 20:59 hours UTC. It will be located in geostationary orbit and is expected to serve the nation for 15 years.